सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ।
Hello listeners, you're listening to Vigyan Ki Awaaz podcast program on STEM popularization, catalyzed and supported by the Ministry of Science and Technology, Government of India and Media for Community Foundation. Project devised and designed by Dr. R. Sridhar and assisted by Ashish Tiwari. Local coordination and production, Professor Subramanian. Content writing by Priyanshu and post-production by Professor Kaushik P. Kanchan of Garden City University, Bengaluru.
Garden City University, conquer we shall all adversity. Together we stand in unity. Together we strive for prosperity. GCU, emphasis on life. GCU, emphasis on life.
We are spotlighting Dr. D.S. Shankar, a pioneering physicist whose work bridges with nano and soft matter worlds. With a PhD from the prestigious Raman Research Institute and international postdoctoral research at SAIT in South Korea, Dr. Rao's journey has been as global as it is groundbreaking. From nanosoft composites to triboelectric effect, his research explores how tiny materials behave under big pressures. A recipient of the Sir C.V. Raman State Award for Young Scientist and a long-standing member, and now treasurer of the Indian Liquid Crystal Society, Dr. Rao is at the forefront of material science innovation.
Myself, Dr. D.S. Shankar, working as a distinguished scientist at RaoCentre for Nano and Soft Matter Sciences. This is after my retirement. I got retired about a year back. So my area is soft nano composite. This soft matter, as the name itself suggests, so it's a with a very low force, it gets sheared. So it responds to the applied field, be it a mechanical or electric field or whatever it is. And this particular electric property, for example, responding to the very low electric field, is used in many of the display devices. So be it a mobile phone, be it at a television screen, or any of the day-to-day thing which you are using, or be it a petrol bank display, everywhere it is used. And our interest is to see study the physical properties of this soft composite, and now the interest is to put the nanomaterial in very small quantity to this soft matter, in particular liquid crystals, and look at the properties. That is my main interest. This in very few places the research on soft matter is going on in India, unlike in other countries, and we are one of the premier research institute and premier researchers conducting research in this field. And any application coming out of this is it can find in application in normal usage. And I can quote one particular studies which I have conducted. So this is changing the three-dimensional helix. See, one of the phase shown by this liquid crystalline material, which we call it as a twist grind boundary symmetric C-star phase. It shows helicity in all the three directions. And this I can alter, I can increase or decrease by putting a small dopant, which we call as azodopant, and shine the UV light. I can change the helicity to whatever number I want, or put a nano rod, for example gold nano rod, and again I can tune it. Or put some dimer azo molecule, and I can tune it to whatever the wavelength I want, the pitch of this helix. And this helix, it can be either in the near infrared region, or it can be in the visible region. So those I can just by shining light or just by putting a very small amount, say of the order of 0.1% of this gold nanorod, I can tune it to whatever number the helix I want. So this we call it as the helix in the optical helix. We call it. This is in analogy with electronic band gap. So this we call it as photonic band gap. And this the tuning property, this can find application in many of the optics, be it a selective reflector or wavelength specific mirror, or in all this optical field it can find application. This is one such property I have quoted, and this is the research topic of one of my research student. But apart from that, I have studied several other physical properties of this soft nano composite, and in addition I have also I'm also doing research in the field of triboelectric nano generator. So that is also another field of research. So the generating electricity, you know very well, this is through hydroelectric power or any other such thing where the carbon emission is very high. But this triboelectric nano generator, as the name itself suggests, this is through the mechanical vibration. So this either by hand tapping or the moving arms or any such thing. So the electricity can be generated, or our walking or through any such thing the electricity is generated. And I am also parallelly interested in the lot of research is going on, and we are also conducting research on this triboelectric nano generator. And one of our result is the we have used the anisotropic property of this liquid crystalline material. For these are rod-like molecules. If it stands upright, it will give one the electricity and current and electricity. If it is perpendicular, it will give the higher electricity and voltage. So just by changing the orientation, I can get different voltages, and again this is through mechanical vibration. So just hand tap it and the current and electricity gets generated, and that is one of my very recent research topic, and where this can find application. This is answering to your research. This can be put in the door carpet. So just there, if you tap your leg, the electricity gets generated, or any of the road signal. So there, vehicle passing, it generates electricity. So everywhere this can be put in.
You were listening to Vigyan Ki Awaaz, a podcast on STEM popularization, catalyzed and supported by National Council for Science and Technology Communication, Government of India. Tune in for more such episodes to Vigyan Ki Awaaz on this platform and also through Spotify, YouTube and Apple Music platforms.
आइए हम सुने विज्ञान की अनकही कहानियाँ।